Hello, chemistry students. This is day 9, April 9th. Today, I want to show you how to identify waves of different frequency using the Smart Notebook software that I now have installed on my iPad. There's a couple things that you need to know when identifying waves of different frequency. You need to know the concepts of wavelength, and you need to know time. So what I'm going to do is what you should see in front of me is a wave diagram starting at 0 seconds right over there on the right side. And then this entire length, this horizontal line, represents the space of 1 second. I'm going to draw several numbers of waves in each of these wave diagrams, and then you'll be able to see what the frequency is. So I want you to always start when you draw waves, start over on the right side. Sorry, left side, and that's left, 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 left that way. Which video I don't know is mirroring or not, but left side. I'm going to select what color should we use, children's. Let's do this bright purple color. All right. So what I'm going to do is I'm going to draw waves of a specific amplitude, first of all, because that's kind of important. This little dotted line is going to help me keep my wave even all the way across. So let's do an amplitude of 3. And if it's 3 up, then you have to go 3 down. And then I'm going to use my purple marker, and I'm going to draw. Let's draw 3 waves in 1 second. So I'm going to go all the way up, then down. That's 1 wave, 2 waves. Oh, it's going to look bad. 3 waves right there. That is exactly 3 waves in 1 second. So 3 waves. Oh, that's awful. Hannah, where's that pen at? That clicky pen that I let you use. Oh, well, I'll just have to use 3 waves in 1 second. Use my finger, it's awful. Okay, now I'm going to draw a different wave, but I'm going to use the same amplitude. There we go. And let's choose a different color because I can. Let's go orange. Ooh, yeah. All right. So now I'm going to draw 1 wave in the span of 1 second, which means I'm going to go all the way up and down. That's the halfway point. Oh, that's awful. That is one awful looking wave. So I have 3 waves on top. That's 3 waves in 1 second versus the bottom, 1 wave in 1 second. Well, you can see the difference in the number of waves in 1 second compared to each other. You can also see a difference in the wavelength. So if I was to measure the wavelength of this, all right, which is the same as the distance from here to there. Well, if I compare that to the wave on the bottom, the 1 wave on the bottom, let's use these markers to show me that it's 1 wave. Well, there is 1 wave. That distance is tremendous, and it should be roughly 3 times bigger than the wave on top. That's how you identify waves of different frequency. Look at the wavelengths. Look at the amount of time that has occurred. If more waves are occurring in a unit of time, like 1 second, then that has a higher frequency versus the one on bottom, which has a fewer number of waves occurring in 1 second. It has the lower frequency. Wavelength and frequency, they 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 match up to each other, and you can consider it like this. Uh-oh, I got a lot of these things here. Let's go back. I'll just write it around here. If you have that longer wavelength, we'll go this. Oh, this is just awful. Looks bad. All right, we won't do that. I'll do it right here instead. All right. So if you have a longer lambda, you have a lower nu frequency. But if you have a shorter lambda, you have a higher, I really need to find that pin, a higher nu. And there you go. That is the relationship between wavelength and frequency, and that is how you identify whether a wave has a higher or lower frequency. You'll have an assignment at the end of this. Make sure you turn that in at the end of the week. It will be on one Google Doc that you turn in after you've done all of them for the entire week. Until then, I'll talk to you later.